Welcome to another video by Meston Educational Services. In this video, we are going to look at anti-differentiation of the type 1 over ax plus b. In other words, it could be ax plus b to the power of -1. Now this could get tricky, so we've got the rule over here. So the antiderivative is normally the coefficient of the x term, which is a, so 1 over a into log of the denominator. But we have to be careful. The denominator, both a and b, should be integer values. If they are not integer values, we have to make them integer values. So let's look at the very first example. I've got 1 over 4x plus 3. So the coefficient of x is 4, so that becomes 1 over 4, and then all I do is substitute ax plus b, which is 4x plus 3, and of course the constant term is c, and then I go and put 4x plus 3 should be greater than 0, because you can't have log of 0 or log of less than 0. So let's look at another example over here. It's 1 over 2x plus 8. Now in this, the first step I have to do is to take a common factor out. So 2 can be taken as a common factor. So that's going to be x plus 4. And in the next step, now what I need to do is to take 1 over 2 outside before I can perform the anti-differentiation. So let's go and do that. So I'm going to write 1 over 2 outside, and then of course inside the antiderivative sign I should just have 1 over x plus 4. So this is going to be now 1 over 2 times log of x plus 4, and I could put it in the absolute value also, x plus 4. Otherwise I can just go and state that x plus 4 should be greater than 0. So that's what it is. So a should be replaced by x, just x there, and that should be 4. And of course then I go and put the condition that x plus 4 is greater than 0. So far these two examples have been pretty straightforward. So just the condition that we need to take a common factor while ensuring that both a and b are still integers. So that's important. Okay, we'll look at another example. It's very similar, but I've got 5 in the numerator. So I still need to go and simplify the denominator, which would be 2 as a common factor and x plus 4. And then I take 5 over 2 outside the bracket. So I need to get rid of that 5 there on top, and likewise this should be written as x plus 4. So this is just a simplifying form, so I get rid of that 5, change it to 1. So now it's going to be 5 over 2 into the antiderivative of 1 over x plus 4. So that's 5 over 2, and now ax plus b should be written as x plus 4. And then of course I go and put the condition that x plus 4 is greater than is greater than 0. Let's go and check on the CAS. So I put the same question on the CAS, and you can see that my answer matches up. Okay, now this one here, the denominator, the constant part actually is a fraction. So I first need to simplify the fraction, because I can't have that fraction over there. It needs to be an integer value. So I'm going to write that as a common denominator. So 2x plus 3 over 5 can be written as 10x plus 3 over 5. And now I need to simplify this further. The 5 from the denominator now can be taken to the numerator up there. So, and the denominator would simply become 10x plus 3. So let's go and simplify that. So that should change to 5, the numerator there. And the entire denominator now should be just 10x plus 3. And now we'll go and perform the antiderivative. So we'll take 5 common, so 5 outside, and then we'll go and find the antiderivative of 10x plus 3, which is in the denominator, which is going to be 1 over 10 into log of 10x plus 3. So multiplied by the new coefficient of 10x, which is 10. So 1 over 10. And then of course we'll go and put log base e, and that should change to 10. and that b should be replaced by 3, and of course we will go and put the condition. But also what I need to do in the next step is to go and simplify. 5 over 10 can be written as a half. So we are saying 10x plus 3 is greater than 0. I can put this in the absolute notation, or the other way I could write is 10x is greater than negative 3. So all of them are acceptable. Alright, so let's go and simplify in the next step. So here I have simplified. So just reminding you that the denominator needs to be simplified to ensure that both a and b are integers. Now we'll go and make a small change to the question. We'll change the numerator to 6 and we'll see how the answer will change. So it's going to be 6. So that needs to be multiplied by 6 as well now. So it should be 6 times 5. So I'll go and put a multiplication symbol, which now changes to 30. So that's going to be 30. And of course divided by 10, which will simplify to 3. So that's the answer on the CAS. Alright, let's look at the same question, but this time I've made the denominator the x coefficient as well as a fraction, and the constant term also is a fraction. So what we are going to now do is simplify the denominator. First step, write it as a common denominator with 15 as the common denominator, and then we'll move the 15 to the numerator, and 15 times 6 is going to make it 90, and of course the rest of it remains the same as it was, except that now that has changed to 9 when I simplify that. So it's going to be 9 times log of 10x plus 9, and we can check that on the CAS. So let's go and change that to 2x over 3, and and that should give us 9 log of 10x plus 9. So that's a minus plus there, and so 9 log 10x plus 9. Okay, one last one. I've got a denominator where I can actually take a common factor out. So you can see in this particular case I've taken 2 as a common factor. So it's going to be 90 divided by 2, which is 45, and then 45 can further be divided by 5, which is going to be 9 log, so 5x minus 6. So the question is very similar, except that I changed it to 4 over 5, and you can check the answer on the CAS.